Hey, now in this class, we will look into the architecture of the Kubernetes part 2. Okay, so basically in this class, we will go deep down into the architecture. And also we have already covered the first part of the architecture in our previous class in which we had discussed about the master node and the worker node. So now we will just go a little bit deep down into that and we will see what we will do today. So here are some of the topics which we are going to cover. So basically the first topic which we are going to cover is the components of the master node, and the second one is which we have the worker node. So I hope you are aware of the master node. Okay, so master node is basically used to manage the cluster and doing all the stuffs. Okay, so let's start with the first topic. So here you can see the one image which we have is the master node. It represents the API server scheduler controller, and this is etcd. So you might be thinking, what is these all things? Okay, so basically the API server scheduler controller and this etcd is nothing but the components of the master node. Okay, so master node is not the single thing. Like inside that we have four components. So about all these four components which we will discuss in this particular class. So let's start with the very first one, that is, and the very important one which we have is the API server. So what is a API server? So API server is nothing but the very first component or the very important component of the master node. Without that, you will be not be able to access the cluster, that the actual Kubernetes cluster. If you want to access the cluster from the outside using your machine, then you will go through the API server. Okay, why? Because API server provides the interface. Okay, it just provides you the interface. Okay, like it may be like a UI interface. Okay, or using command line tool also you can do. You can access the Kubernetes cluster. So here are some of the points which are mentioned. You can see like it is the main gateway to access the Kubernetes cluster, and also it is a central component of the Kubernetes control plane. So now you might be thinking, what is this control plane? So it's nothing but it just represents your master node. It means the control plane is simply means all the set of components which are used to manage the cluster. So obviously master node will be the one. Okay. And the third point which we have, you can see here, the exposing APIs which allow user to interact with the Kubernetes cluster. So it simply means like making the Kubernetes API server accessible to other components such as client tools or web UIs. Okay, so exposing API is just that simple. Okay, it means that. And the tool which we use to access is kubectl or web UIs. Okay, it can be used to interact with the API server, and it is also responsible for validating the request. What does this line refers to? It simply means like whenever one client will request something from the API server. So it will first validate that request, whether that request is valid or not. Okay. So after validating the request, that request gets approved, and then the client should be able to access that thing or do whatever operation they want to do. Okay. So this is about the API server. I hope you got it. And then next, moving forward, we have another one is scheduler. Okay, so here you can see the scheduler. Scheduler is nothing but, as the name suggests, here you can see a scheduler is nothing but which is used to schedule the pods. Okay, so basically what happens, like here you can see the first point, like responsible for scheduling pods or nodes. What does it mean? It simply means like whenever a new pod is created in Kubernetes, so what happens at that time? A scheduler selects a node for the pod to run on. Okay. So what will happen whenever a new project whenever a new pod is created, okay, when a new pod is created, and then after that what will happen, like it is not like randomly going and work on some particular nodes. So like you have seen in our previous class, here we have discussed like in the in the worker node we have pods, and in pods we have containers. Okay, so here it's removed actually. So here we have suppose containers. Okay, so what happens, like scheduler, what it does, the role of that is it just checks the what is the requirement of the pod and what are the specification of that pod, and then it decides on which container that pod should run. So that is the main like work of that scheduler. Okay, I hope you got it. And also like some of the points like is there, like the scheduler obtains the information from the etcd via the API server. So whatever the information should be there about the specification and the configuration, they access it from the etcd. Okay. And moving forward, we have the control manager. So control manager is nothing but, as the name suggests, you can see it just controls the or manages the cluster. It means monitoring happens there actually. So in that we have the kube control manager, which is responsible to inform the node. Like suppose in the cluster, if some node fails, so what should they do? Like the kube controller just sends the signal to the master node, and then whatever the action should be done, it is performed. Okay. So in Kube Control Manager also we have four controllers. We have like node, replication, service, and endpoint controllers. So these controllers actually work in the work not separately. They work together. Okay. So the node container, all these four containers work together. It's a single unit. So here are the some of the points. Like node control what it does. So node control is basically used to monitor the nodes. Suppose if any node fails, then it just sends the report to the master node. And the replication controller is this maintain the current replica count. It means like maintain the current replica count. It means, so the thing is like what happens whenever user creates a pod, or whenever they deploy one pod with a specified number of replicas. So at that time what happens, the replication control ensures that this desired number of replicas is always maintained. Okay. Suppose you are a user and you are going to deploy one pod, and at that time you just you also mention that that number of replicas should be there. Suppose you are deployment one pod and you are giving it like three replicas should be there of that pod. Okay, so in that case what should happen, if that replica goes down, like suppose one fails, then replica remains two. So then that replication controller came into the role. It then again try to restart that pod and that replica, and then it maintains. Okay. And the service control is nothing but it just check whether all the services are properly configured or not, and the endpoint control is just to make sure all the endpoints should be accessible and it should be working. So this is about the control manager. And the last one which we have is the etcd or etcad. You can pronounce anything whatever you want. So it's nothing but the key value database. It is basically just like a log, like whatever the event happens in the cluster. Like suppose one pod fails, and then one pod starts, or the node fails, node starts, node created, pod created, whatever the thing happens inside the cluster, it is just recorded into this etcd database, and it's actually a key value pair database. Okay, and it can only directly accessed by the API server. Okay. Okay, so this one is the whole thing about the master node, components of the master node. Now moving forward, we have the worker node. So in the worker node also we have some what we see in worker node also we have some. Sorry, I did something, I guess. Wait. So in worker node we have kubelet and kubeproxy. So these two exist. So we will look into it how this thing actually works. Okay. So kubelet is nothing but it runs on each worker node. Like this is one particular worker node. Okay. So that kubelet runs on every worker node. Similarly, like the pod which is there on the worker node, in the same thing, kubelet also works on the every worker node, and it is basically used to manage the state of the pods. Okay, pods, running pods. Okay, like whether it fails or whether something happens to the pod, it just reports to the master node. Okay, so basically how does this thing work? So it basically works based on this pod specification. Like it is nothing but it is defined in the JSON or YML file, and inside that we get some parameters, like we get the metadata, specification, and the state. These fields are present inside that JSON or YML file, and based upon that kubelet decides what to do. Okay, so and also it makes sure whether containers with whatever the container which are running inside the pods. Like here you can see I have one container. Just suppose you think it like as the container, and this is one pod. So like kubelet make sure like every container should be running always. And we have kubeproxy. So kubeproxy is nothing but it is responsible for managing the networking aspect of cluster and the network configuration and the rules. So suppose networking things like IP addresses, DNS, all those things is managed by the kubeproxy. And the last one which we have is the container runtime. So container runtime is nothing but the software which is responsible for running the container. So actually Kubernetes does not provide the some direct way to run the containerized application. So that's why this container runtime came in the role. So this is basically nothing but the Docker. The Docker is the most famous and the most preferred and the most used containerized app software which we used. Okay, so there will be Docker. Okay, so this is all the things. I hope it is clear, all the components of the worker node and the this one master node. Okay, so I hope you got it everything whatever we have discussed. If you have any question, you can ask us. So we will stop here, and I'll meet you in the next video. Thank you for watching.